All right, combining like terms. Okay, we've seen terms throughout our mathematical careers, but we may or may not have learned how to combine them. Maybe we did in 7th grade a little bit, possibly 6th grade. But anyway, it's going to be a big thing for us this year. So here is kind of an overall definition. So terms are just they're parts of an expression that are to be added or subtracted. The like terms are the terms that contain the same variables raised to the same powers. Okay, so we do have a little example here to the right side. The like terms are the red ones, so 4x and minus 3x. Okay, they have the same variable attached to it in x, and those variables are to the same power. And then they also talk about constants. Okay, constants are like terms. So a constant is just a number that does not have a variable attached to it, and those can be added or subtracted just like we normally have. So let me give you some examples of like terms. Like would be, let's see, y to the third and negative 4y to the third. Those are like because they are both to the same, or they have the same variable and they have the same power that they are raised to the third power. One thing to point out, if you do not see a number in front of a y to the third, you can assume that there is a 1 there. Other like terms, if we had something like 2x squared y and 5x squared y, those would also be like terms, okay? Because we have the same variables, and the x is to the same power, and the y's are also to the same power. Those are like terms, which means they can be combined. So for instance, if we go back up to this red section here, the like term, I can simplify this expression. 4x, I look for something else that has an x, and I always include the symbol before the term, because that will indicate whether it's positive or negative. So you can think of this as 4x plus negative 3x, or 4 plus negative 3, which is 1x, and then we have plus 2. And now this expression is simplified. Alright, so it's kind of like asking, okay, if I have 4 x's and I take away 3 x's, how many x's do I have left? We have 1x left, and then a plus 2, a constant, with that expression. Okay. One other thing to note here is, what if it was written like this instead? Let's go negative 7yx squared. Is that also like the other terms over here? It actually is, in case you were wondering. Y is still to the first power, x is still to the second power. Remember, it doesn't matter what order we multiply those things in. It could be x squared times y or y times x squared. This is also a like term. So if these were in an expression together, they could all be combined. They are like, all right? So that's what like terms are. Same variables to the same powers. Okay? Now the numbers out front of those variables are called coefficients. It's the number that multiplies a variable. And we just talked about this up on the other part of the screen, that a variable written without a coefficient has a coefficient of 1. So for instance, like right here, x squared and 1x squared are the same thing. Okay, you can always, if you don't see a number, you can put a 1 there, because 1 times anything is the same thing, right? So that's how we can talk about that. All right, so examples here, and then that'll be it. Okay, I tried to give us a different array of examples, so I'm going to start with A, B, C. All right, so let's look at A. I look at my first term, 5x, and I look for anything else that has just an x with it, and that's it. Okay, so I notice that negative 2x is also in there. So I can think of this in two different ways. 5x plus negative 2x, or 5x minus 2x. Either way, I'm left with 3x. Alright? Then I move on to another term. And remember, keep those signs with them that are in front of them. So for instance, this sign let me know that the 2 was negative. Now I know I have a positive 3. Okay? Oopsies, sorry, just trying to do this whole thing. Alright, so we have positive 3y plus 1y. The y's are both to the same power, so we're good. So 3y plus 1y is 4y. And if anything comes out positive, we can just put a little addition symbol, and we are simplified. 3x plus 4y. Alright, let's look at b real quick. Now we have a little bit more involved. Okay, so remember we want to look for same variable, but also to the same power. So all of these terms have the same variable. They all have x's with them, but they're not all to the same power. So for instance, if I look at negative 2x to the second, I cannot combine it with the second term because that's an x to the third. But I can combine it with positive 8x to the second. So these two together, it's like negative 2 plus 8 is 6. Or negative 2x squared plus 8x squared is 6x squared. Now, negative 4x to the third doesn't have a partner, but that's okay. We just drop it down and write it like this. Okay. And some of you are probably wondering, does it matter what order I write the terms in? We'll talk about that a little bit in the near future. Most of the time, we write the largest power first and go downward. And that's what you'll see as the year goes on. Not a huge deal, but I could write this as negative 4x to the third plus 6x squared as well, because this is positive. So I could write it like this. These are the same thing. Okay. And what, like I said, you'll usually see that the highest power is the first one, and then it decreases as we go to the right. So that's usually how it will be written, but that's not necessary at this point. It's just usually how it goes. Okay, letter C. 2x to the second times y minus 3x to the second times y to the second plus 2xy. This particular problem is already simplified. The reason being, we can't combine any of those terms. They do have all the same variables, but they're all to different powers. So we can't combine any of those things. All right, and lastly, we're going to bring in the concept of distributing and then combining like terms. So, for instance, if you use the method where you just distribute like this, so I have negative 7 next to a parenthesis, I'm going to distribute to this. Negative 7 times 2x is negative 14x. And then negative 7 times negative 4 is going to be positive 8. So negative times a negative. Some of you write that as minus negative 4. That's fine, but remember that will turn positive anyway. And then we also have a plus 20x hanging out. And now after you do your distribution, you want to look for anything you can combine. I can combine negative 14x and 20x. 28 doesn't have a partner. So negative 14x plus 20x is going to be 6x, and then we have plus 28 hanging out. And there's our final answer. If you do this the box method way, where we take the distribution part and we turn that into the box method, where we put negative 7, 2x, and minus 4, or negative 4. So negative 7 times 2x is going to be negative 14x. And then negative 7 times negative 4 is going to be positive 28. And then we can take this and just write it underneath the box that it can be combined with. So for instance, I know I can add 20x to negative 14x, and I get 6x plus 28, and you get the same answer. So in other route you can go. Takes a little bit longer, but it does organize things very well. All right, so that is combining like terms, and we'll work with this pretty much the rest of the year because it'll be something that we always come back to in specific problems to help us simplify.